Hello, everyone. Welcome to today's IQB seminar. We have an interesting talk today. We have two speakers from the PyMOL team. I don't know how many of you have used PyMOL, but if you've ever had a chance to interact with structures of molecules, you might have come across this uh, tool for visualizing molecules. And I've had very good experiences using PyMOL as a grad student. I guess that's when PyMOL came into picture, and we in our lab we were excited to see how you could just load something and hit pretty picture or publication and just have a very nice instantaneous representation, and that was cool at that time. And I've used myself used PyMOL quite a bit, and we have Thomas Stewart and Jarret Johnson from Schrödinger joining us today. Jarret Johnson received his PhD in chemical biology from University of Michigan, where he studied computational protein structure prediction and side chain rotamer modeling. His doctoral work explored how rotamer states can be used to improve protein fold recognition and computational protein design. After completing his PhD, he joined Schrödinger to work on PyMOL development. He is now the PyMOL technical lead, where he works on visualization features, rendering systems, scripting infrastructure, and the overall architecture of the software. Welcome, Jarret. And we also have Thomas. Thomas completed his undergrad and master's in biomedical engineering at the University of Michigan. His research in undergrad was in the same lab as Jarret, and he focused on protein design, expression, and purification. This is where he found his passion for PyMOL, like many others, I guess, and jumped at the chance to join the team after grad school. He has worked on PyMOL for the past 6 years and primarily focuses on the overall user experience in improving the interface. Welcome to Rutgers and IQB. Thomas and Jarret will be presenting the seminar titled Advances in Visualization.
All right. Thank you all for coming. Just as a disclaimer upfront, I'm a software developer, so I'm not used to presenting for an hour, so I may lose my voice here towards the end. But yeah, today we're going to be talking to you about PyMOL. So from the intro, Jarret and I are both PyMOL developers and have been working on it for years and have made pretty substantial changes to the overall interface. So for those of you that don't know what PyMOL is, we'll start with that. What is PyMOL? So PyMOL, as we learned about in the introduction, is mainly a visualization tool. So I draw this distinction between PyMOL and a lot of our other Schrödinger tools that are focused on some of the more computational or heavier aspects of bioinformatics and computational biology. But PyMOL is really, really good at creating these stunning images. It looks a little bit better in person. The projector kind of washes this out a little bit. But it's also really good for creating these insightful movies. I'm gonna switch. Can I use this microphone? Yeah, all right, sorry. I feel like the other one was cutting out a little bit. So with this, PyMOL is very, very popular. So PyMOL is well regarded and used kind of all throughout industry and academia. So this is not just a academic product. This is also something that is used by basically every large pharmaceutical company in the world. And it generates a lot of excitement and hype. A lot of people have really positive stories to tell from their use of PyMOL in grad school. But basically, it is very well recognized. And yeah, I'll give you a little more of a convincing argument for why you should learn how to use it if you don't already use it frequently. The last point I want to make about what PyMOL is that it is simple and lightweight. So intentionally, we make PyMOL as easy to use as possible with the goal that this is something that undergrads can pick up for the very first time in their introductory biochemistry class and look at a structure. I'm sure many of you also remember your first intro biochemistry class or the first time that you saw a protein. But for me personally, that was really where I kind of, again, being a little facetious about found my passion, but genuinely when I got to see these proteins in 3D, I feel like that really did click in terms of these things aren't just blobs in a textbook. They are actual structures that are doing something chemically. And that made me far, far more interested in this topic in structural biology in general, strictly because I was able to see these images, right? And so with PyMOL, we really want to encourage that kind of experience as much as possible. Okay, I'll go through this very, very quickly, but just again, kind of underscoring how widely PyMOL is used by hundreds of thousands of people over the years. A lot of these people are using it at a very, low level, but there are people that use this every single day for their actual scientific work. And this number might be a little bit off, but basically whenever the new semester begins, we tend to give out around 8,000 educational licenses every single month to students. These are given out for free, and they are basically full license for PyMOL to use the full feature set for educators and their students. So again, encouraging that initial kind of discovery and getting people to create these images and movies for the first time. And PyMOL is quite old at this point. So it's been under development for over 25 years, and 15 of those have been with Schrödinger. So things have obviously changed pretty considerably in the computational space since then. And part of what I'm going to be talking about today is how we are trying to modernize PyMOL and ensure that it stays relevant as things have changed so much in the last quarter century. Yeah. Cool. This is just a little slide I threw together. This is a bunch of different journal covers from over the years. These are all pulled from our PyMOL Wiki gallery. But again, just kind of underscoring how not just widely used PyMOL is, but also the impact that it has on the broader scientific community. People, especially on journal covers, really, really like to see these pretty looking structures. And I mean, you can tell just from the variety of images here, take the time to really make things look unique or tailored to whatever story that they're trying to tell. Okay, so with this, I'm going to talk through our motivation for developing PyMOL 3.0. For context on this, PyMOL 3.0 came out about a year and a half ago, maybe a little bit longer. The reason why I'm going through this is mainly to kind of give you a little bit of insight into how we think about PyMOL development, about software development in general. And I just did all these slides talking about how popular PyMOL is and how great it was. And basically, like, why should we even bother developing it, right? We already have this great product. Why should we try to improve it at all? Well, first of all, this is an older image from PyMOL, and there's a lot going on here. I know it's kind of hard to see on the projector, but we have in the bottom left, there is a bunch of little green numbers. There's a track along the bottom that has all these bars and a whole bunch of objects, all of which, again, very difficult to see on the projector. But the main point that I want to convey with this is for a student that is opening a product or a software package for the first time, this is a lot to throw at them. This is a lot of information. This is kind of overwhelming. You're probably already a little bit out of your depth. And so what that can do, though, is mean that people are unwilling to try or are maybe not as willing to explore because there's so much complexity that's thrown at them right up front. Related to that, but a little subtly different, is obscurity. There are a lot of PyMOL features that have existed for a long time that even seasoned PyMOL pros have no idea even exist because they're either hidden behind a whole stack of menus or you have to know specific keyboard shortcuts. It's this kind of like secret arcane knowledge that has been created and then lost over the years. And so we really wanted to make sure that all of the main features are easy to find and front and center. And then the last point is the kind of outdated interface. I actually love how PyMOL looks. It kind of has this like very early 2000s vibe to it because that's, when it was created. But this does have a little bit of downsides in terms of there are a lot more modern packages out there now for kind of graphics development or GUI development. And especially for, again, think of a undergrad that's coming into a software program for the first time. They are used to much more modern looking interfaces and are going to have intuitions that come from having used software for their entire lives. And I'll point out some specific examples of what I'm talking about here in a moment. So with that, I want to introduce the PyMOL 3 interface. So this interface, a little more modern looking. Again, I'm sorry, this is going to be hard to see on the projector, but just from what you can see, even with this zoomed out blurry image, you can see that the overall view is a little bit less cluttered. It's a little bit more intentional, and there's at least places where you would start to look for various different features. So just to provide some vocab, because I'm going to talk more extensively about each of these features individually, we have this new top toolbar. And this is one that I really want to highlight. Again, I'm sorry if you can't see this from the back, but the top toolbar now has the, for instance, selection mode and then undo redo buttons here. Oh yeah, I can use my mouse. Here in the top left. And this is a great example of something that new students that are coming into the software package know that this is where they should be looking for undo redo, right? That is an established paradigm in a lot of other software programs that did not exist, 20 years ago or whatever. And so we've had undo redo. I'll go back to the previous image. We've had undo redo for a long time, but a lot of people didn't even know that it existed, right? Because it was not fully hidden away. I mean, it's right here with all these other buttons, but oftentimes people don't know to look here, whereas this is a recognized thing that people immediately jump to, right? So that's a single example, but that exact kind of paradigm, that's what we've applied to a lot of this interface is in terms of putting things where people would expect them to be or kind of initially look for so that they are more discoverable and you can start using these features within PyMOL that we've worked really hard on and they don't go unnoticed. So that's the top toolbar. There's some other key functionality there in the top that we'll talk about later. Next is the redesigned contents panel. Again, I'm sorry if this is hard to see, but the idea here is that we wanted to modernize and convey a little bit more information with this contents panel, but keep this Ash LC. Again, these are the colorful buttons that you can hopefully see in the top right. This is our menu system. The goal was to keep this more or less identical so that people that already know how to use PyMOL, it's a seamless transition. But for those people that are not as familiar with PyMOL, it's a little bit more of a modern interface and also has this very nice, this very nice toolbar along the bottom here, providing even more access to the main tools that you want to be using within PyMOL. Next, we have the scenes panel. I'm partial to this because I spent a long time making this look nice. But if we go back, I'll go all the way back to the previous interface. Those little green tiles in the bottom left that are just numbers in this case, those are our scenes previously. And so these are very, very helpful for basically storing a snapshot of what your interface looks or what your workspace looks like. So if you have a particular pose, styling, coloring, things like that, as you're working on these broader projects, it's very, very helpful to be able to store these kind of checkpoints as you go. But as you can imagine, you create 11 of these things. Well, are you going to remember what number 3 is, right? Like it's very, very challenging, especially when you start working on these larger projects. So being able to actually see the literal scene that you are using is a far more intuitive experience and, again, dramatically speeds up how quickly you can actually start creating these images and movies. Last but not least, the real kind of star of the show here is the new timeline. So this is a much more feature-rich movie creation experience. We're going to be doing a little bit of a demo here towards the end of the presentation or when I get to this. But basically, it makes it much, much easier to convert scenes or camera positions or whatever you'd like into a movie that is functional. It's much easier to edit these things now, drag them around. Again, think of a modern video editing software. It's going to look something much more like this. And again, we really wanted to bring this into the modern era. Again, I'm sorry, I'm going all the way back again, but compare that to these little purple bars at the bottom, right? Much, much more challenging to interact with, and oftentimes, again, very easy to forget what any particular time point is meant to represent here in this old view. So I've gone through all that. Again, the main thing that I want to convey with all of this is that the purpose of these changes are to make our features more accessible and ideally improve the overall experience so that people are willing to go in greater depth when they are creating these images and movies rather than just clicking a single button and hitting export. Okay, so why should you use PyMOL? I know a lot of you are probably maybe not even concerned about using PyMOL. You can just pull it up in Molstar or in some other viewer and then get an image of your protein, right? Well, the argument that I want to make here is that with PyMOL and really going into these advanced lighting settings, you can create images that convey more information to your audience. I don't know how many posters and presentations and papers I've seen where there are these figures of proteins that are very challenging to tell what you're supposed to be looking at, right? It just looks like a protein. Great. Okay. If you already read the whole paper or you already understand the research, you may know what you're looking for. But for most people, again, think a poster presentation at a conference or something like that, they're walking up to your poster, they do not know what they should be looking for. So actually spending a little bit more time doing things like in this image that I have up here, I probably spent half an hour creating this in terms of adjusting the lighting settings, adjusting the focal blur. Again, this isn't like a super scientific image, obviously, but there is no doubt what I am trying to draw your attention to, right? There's very clearly a ligand here. This is the focus of this image, and this is what I want to draw your eye to. Again, you could imagine doing something very similar for particular interactions or particular domains of a larger protein. All that I'm trying to convey with this is that it is worth your time, especially for things that are, again, these kind of like final presentations where you've done all this research over months and months. It's worth taking an extra half hour to really create an image that conveys what you're trying to get across. And this will, I mean, this sounds dumb to say, but like genuinely pretty pictures draw people's attention like crazy, right? If you want to get people's attention at a poster presentation conference, have the best looking images and people are going to be very interested in learning about your work. So all that to say, it's worth your time to actually invest in creating these images. Next up, I feel very strongly about this as well. Movies are much, much better at showing 3D than any static image is ever going to be, right? Obviously, this is not super applicable in the context of a poster or even certain papers, but increasingly we're seeing more and more journals that are not just interested in including some of these images in movies that are animated, but they are encouraging it, right? They want to be able to show what you are actually trying to display in a more dynamic way. And especially if you are presenting at a lab meeting or doing anything that involves something like this, where I'm presenting to lots of different people, it is far easier for us to see what this looks like in 3D with this very, very simple rocking GIF. Quite literally, I made this in PyMOL in 5 seconds. I pulled in a PDB, I zoomed in on the ligand, I stored 2 camera positions, and now we can actually look at this thing in 3D, right? Very, very simple, and certainly worth your time if you want to actually have a discussion about what these structures look like in 3D. Next, PyMOL has a long history, again, 25 years of development. But over those years, people have invested a lot of time into developing plugins and scripts and presets, all of which can be found online. The other thing I would like to add to this, which we'll talk a little bit more about AI a little bit later. I promise it's a good thing. But PyMOL has incredible Googleability, I guess is the best way of putting it. If you type in PyMOL and then whatever you want, Google, because there are so many resources that have been developed over the years, you are going to get much, much better answers than with some of these other platforms that are a little bit newer or don't have as much public-facing information. That's also worth mentioning. I guess I didn't provide that context at the beginning. There's kind of 2 versions of PyMOL. We have the open source version that we also maintain within Schrödinger, and then we have our incentive version. The incentive version is still given out for free to students and teachers, but otherwise it is a like paid license thing because we're actively developing it, and that's where most of what I'm showing you is coming from. But there is also open source, which again makes it even more Googleable, and you can actually look at the code for most of what we're doing. Okay, and the last point I want to make is that it's easier than ever to get started with PyMOL. Again, this is more of a concern for undergrads that are coming into your lab or are interested in creating these images quickly. We have a lot more resources now on our product page. Again, you can just search PyMOL Schrödinger or just even PyMOL and go to pymol.org. But we have an online course. It was developed by Schrödinger that's totally for free and probably takes an afternoon or 2 to go through. But I mean, again, for free for an undergrad at the start of a summer project or something like that, they can become basically fully versed in PyMOL in an afternoon or 2, right? And then start really creating these very cool looking images and movies. All right. Next, I want to talk about the future of PyMOL. I'm going pretty quickly. So this is a small subset of all the different features that we are currently working on within PyMOL. The ones that I'm going to talk about today are on the pretty near term horizon, but are not in a release yet and are not fully developed. So if you guys have any feedback or features that I don't talk about here today, this would be a good time to also talk about them in a second. We'll do a kind of like question session after I go through these, and then we'll also do a demo after that. Okay, all that out of the way, the future of PyMOL. So the first thing that we're really trying to improve is the handling of cryo-EM maps, volumes, and just cryo-EM data in general. So when PyMOL's volume rendering tools were originally developed, this was, I don't know, probably 10 or 15 years ago at this point, cryo-EM really wasn't on the scene yet, right? Cryo-EM was a newer tool. It certainly wasn't being used to the same extent that it is now. Now it is a mainstay, and increasingly we're seeing even more and more structures coming out that use this kind of map data. So again, I'm sorry this is kind of hard to see on the screen, but we are basically working on a new panel here that will enable some basic map editing and fitting in PyMOL itself. Again, the map that I've loaded in here is an example where we've removed all the dust. So all the little fragments that are below a particular, I guess, volume really, but below a particular size are able to be filtered out now so that you can kind of automate that initial process and then, again, move into actually fitting these things with a model and kind of taking it from there. One general category, again, I can do a demo of that later on if people are interested. Next, binary CIF. This is going to be in a upcoming release of PyMOL as well. We have a code review for it right now. I don't know if it's been merged in yet. I don't think it has.
Import yes, export no.
Okay, so we are able to import binary CIF, but not export it yet. But we are really excited about this in general, and I am personally trying to push for broader use of binary CIF within Schrödinger as well. I mean, I think it just makes a lot of sense. But yeah, again, kind of expanding our support for these more modern ways of storing information. Okay, agents and AI. So here, I'm not talking about integrating AI fully into PyMOL. That's a separate conversation. What I'm talking about here, though, is with all of these LLMs that are available online. So think, in this case, I'm showing Gemini, but Claude or ChatGPT, I don't know why I couldn't think of that. All of these are all trained on the internet, right? The entirety of the internet. They've been trained on the last, 10 years of the internet. And guess what has a lot of information on the internet from the last decade or two? PyMOL, right? So I would say that of all of the tools like this, PyMOL is probably the most well-suited to actually get good results out of, again, because there are so many scripts and, again, our entire open source repo for it to be able to train on, it is really, really good at producing these scripts. I know none of you are going to be able to read this, unfortunately, but what I'm asking for here is I have a paper and there's a bunch of residues that are listed for these different, basically like motifs within the broader structure, and I want those to be labeled. I'll show you what this ends up looking like later on in the presentation, but I said, hey, create a script for me that's going to label all these things, create all selections for these, and later on in this little prompting session, I say, oh, I actually want to only select these type of atoms, or I would like the labels to be colored this way. And it is able to produce a fully functional script in, literally seconds, right? And so this makes it much, much easier to actually iterate and kind of go back and forth as you are working on these things within PyMOL, and you don't need to necessarily look up all these individual things and type out all these individual commands. So I would encourage, if you are just trying to get started with PyMOL in the first place, or you want to create these more automated scripts that are going to make your work a lot faster, any kind of online agent is going to be good at it. It literally doesn't matter which one you're using. It's not always going to be perfect. You still need to check it. But thankfully, the kind of like, I don't even know, the cost of being wrong in PyMOL is also a lot lower. We're not kicking off these massive computational jobs that are spending thousands of dollars. If something is colored purple instead of blue, it's not that big of a deal. So it's a little bit easier to kind of iterate and play around with these AI agents. The next topic I want to bring up is graphics and performance. So again, just thinking about how far really graphics has come in the last, again, even 10 years, but especially 25. GPUs are now a lot more prevalent and a lot more powerful. And so we're working on a couple different ways of kind of leveraging this, both for improving graphics, doing kind of real-time ray tracing, material properties, things like that, but also for these more computationally expensive surface generation, those type of calculations. All of those can leverage the GPU as well. So this is a giant structure that I'm showing here. This is a flagellar motor that if you want to ray trace or generate a surface for, takes a very, very long time using the CPU, but is very, very fast when you're able to use the GPU. So again, just another category that we're trying to improve. This was a intern project over the summer this year that we're pretty excited about, is basically direct being able to pull in AlphaFold structures. So again, this is very, very popular with undergrads or those that are just kind of dipping their toes into structural biology in the first place. So basically there's a panel, which I didn't include in this, but you can input whatever uniprot ID that you'd like, and we pull in the structure with the corresponding coloring and then a plot that demonstrates basically the confidence. So some of them look like this, some of them look a little more like this, but this is still very useful information. And again, especially in the context of undergrads that are initially learning about protein structure, being able to show slash have them understand why this is a actual protein or probably is closer to the truth and this is spaghetti is a relevant lesson, right? And being able to see the confidence plot and the coloring here is very, very helpful for that. Okay. So I went through that a lot faster than I thought I was going to. I guess I was flying. So I want to leave this open to questions right now. If you have any questions about anything that I presented on here today, I want to first talk about those. We could also talk more about software development in industry more generally. And then if there's anything in particular that you'd like for me to demo, I want this to kind of be guided by what you are most interested in. So I will open this up to the floor for questions.
I have a whole bunch of questions, but let's start with a simple one. You're talking about AI agents and everything. Has anyone published supplementary materials where they provide the scripts that they use to produce images that you're aware of? Because you'd think that would be something that would be trivial, like someone could just put it, in a PDF or something like that.
Yeah, absolutely. Sometimes they do. There are definitely examples of people, and especially even more historically, where they will include that information. Sorry, should I repeat the question, or was that okay? Yeah, essentially, they will sometimes provide their scripts, especially in the like supplemental information of these papers. Oftentimes, though, we don't see that, and we don't even always see people credit PyMOL for generating these images in papers. We're not. I mean, overly litigious is the wrong word, but we're not, going after people for not citing PyMOL. But oftentimes they think of this image generation as like a secondary thing, and it's not necessarily of interest to reviewers or anything like that, where they would want to see these scripts be included in the publication.
Thanks for Hello? Okay. Yeah, thank you for the great overview on the new release. I just had a question about you briefly mentioned the binary CIF support. I'm just curious, like what kind of support you're referring to? Like you can read in binary CIF, export it. Do you pull it from the web or?
Jarret just did this.
Okay.
Last
Great.
week, so.
I guess yes to all of the above. We already had a CIF importer and exporter, but now we just need to just support the binary version of it. But yeah, as far as I understand, as Thomas was saying, it's going to be in our next version of Incentive PyMOL. It's going to support both import and export. If you're actually using the open source version, it already supports import and export of binary CIF.
And again, I think the real exciting part of binary CIF is for some of the more computationally heavy programs where you need to be passing around these files that can be quite large if they're not in a compatible format or in a relevant for transferability. So that's where it's a lot more exciting. Again, adding that support in PyMOL, though, is kind of the first step so that you can start using these as actual exports from other tools.
Hello. One thing I heard you briefly mention was like testing out like different materials that you can use for visualization. I've used a tool like a plugin for Blender, and it's been really fun to be able to like make some really cool animations and visuals there. I was wondering what that is like. Yeah, go ahead.
I've been a heavy Blender user since when I was like much younger. When I was actually developing like the timeline, a lot of my inspirations actually come from Blender. And a lot of what we're actually going to do in PyMOL 3.3, it's actually very inspired by Blender. And as far as materials go, it seems like a lot of the graphics world, especially in video games, are moving towards like PBR. So you're going to see a lot of things like the BRDF model thing looking a little bit more sort of quote unquote real. So we're going to probably use the BRDF model rather than like models that were made like 15, 20 years ago. We're going to be stepping that up a bit just so people have more control over how their proteins interacts with things like lighting and stuff like that.
You can keep that.
We'll take one more question here and then do some online.
So I had a question about specifically visualization. I know a lot of people are moving to or using Ovito. And what do you think the strengths of both programs are in terms of visualization? And are you trying to kind of implement GPU rendering like I think Ovito does?
Oviedo?
Oviedo, yeah.
I don't know if I've
I've
heard.
never heard of
Oh, really?
Oviedo.
Oh,
Yeah.
yeah. So,
But I guess the general question is, what are we doing with rendering on the GPU? So most of what PyMOL does rendering is already on the GPU. We've been using um, actually a very old sort of graphics API called OpenGL. A lot of you've probably heard of it if you've ever played games or if you've ever interacted with visualization programs. And I think even most of the other molecular visualizers out there still use things like OpenGL. But as we're looking more towards the future, there's limitations of what like OpenGL can sort of provide for us. If you've ever used PyMOL, one of the more exciting things that people have used is like ray tracing. But as Thomas said, like as your structures get bigger, so does the rendering of a ray traced image. But with advent of things like Vulkan, which is one of the newer sort of open standards for graphics, we can now do ray tracing in real time now. So having to wait minutes for a ray traced image now just becomes just a matter of maybe just like a couple of milliseconds, and you can just like now render out your image or your movie in a few seconds rather than waiting hours to days. Yeah, I'll just keep this mic.
Yeah, we have some questions online. I'll just read it out. How do we get the multiple sequence alignment file of multiple superimposed structures? So these are, I mean, I think these are very specific documentation kind of questions, but it's up to you if you want to take it up and answer that.
I would probably have to see it.
Yeah, I'm not sure. We'd have to see the actual
Okay.
files here.
All right. The next one is Boltz 2 incorporated in PyMOL 3.0?
So what was the first two words?
Boltz, Boltz,
Mhm.
Boltz 2.
Oh, Boltz 2. We don't have any direct sort of integration with Boltz 2, but I'm sure someone probably could just make a plugin. But as far as I understand,
Yeah,
not,
we're
especially
not
since-
likely going to be the ones to do that.
Yeah.
That's a
Got it.
Also, it's probably like a Schrödinger.
It's a direct Schrödinger
not
process, yeah.
something we're
Yeah.
probably going to do likely.
How do we restrain the ligand in the active site of the protein using PyMOL? Again, this is very specific documentation kind of question.
Yeah, absolutely. I think more broadly with a lot of this stuff, the point that I want to convey, and I hope I conveyed in my main presentation as well. We have to, we really struggle with this balance of like the computational tools versus just being a viewer, right? And so there are things that kind of bridge the gap in terms of like if you wanted to calculate solvent accessible area or the number of residues that are around a particular ligand, like those kind of distance-based things, very, very easy. But in terms of doing any kind of like actual docking or constraining a ligand or using a reference ligand for any kind, like all that gets into territory that is now full computational biology, and we try to avoid wading into that as much as possible. There's a different Schrödinger product called Maestro that is really, really good for all this and has direct integration with all the other Schrödinger tools. Yeah, it's far, far more powerful. And PyMOL, yeah, again, tries to stay out of that realm as much as possible.
And there's a lot of other scientists out there who probably have the same questions. So for those who are unfamiliar, PyMOL has a mailing list, and for those who have questions, specific questions like these, especially if it sort of leans towards like what sort of custom plugin should I use that's been created and curated by third party, I would say the mailing list would probably be the best sort of venue to ask specific questions like these if PyMOL doesn't support it out of the box.
Is there an official Google Colab notebook for PyMOL open source version for tutorials? And there are some general questions about where to learn more about
Yeah,
PyMOL.
absolutely. There is no actual notebook for PyMOL learning, but if you are interested in learning more in general, PyMOL.org. You can, again, just Google this. There will be a link at the top that takes you to our product page, and that brings you into the Schrödinger environment. And then at the bottom of the page, which I showed in one of the slides, there's a link to our online course. You can also just Google PyMOL Schrödinger online course, and you should be able to follow the link that I believe should be the first one. I don't know. I haven't checked recently. But yeah, basically, you should be able to register for the course and then take that totally for free.
Okay, we'll take one more from online. Sorry. Okay. What about a WebAssembly version of PyMOL that's provided with live design? But what about an open one?
Stay tuned.
Stay tuned. Yeah, that is a very, very good question. For context on that, basically we have a different Schrödinger product called Live Design that is best thought of as kind of like a spreadsheet for different drugs, compounds, and the ability to run various different computations on those drugs. The 3D viewer is basically a web version of PyMOL. It was developed a long time ago and is now, again, a little bit, it serves its purpose very, very well, but it struggles with larger structures. And so we're investigating basically improving that and then productizing it as a separate offering as well.
We have a lot of viewers online and so many questions. I'll just take one more. Are people integrating headless PyMOL into computational biology workflow since it's a natural way to represent and manipulate protein structure? If so, any best practices we should know?
I don't know about any best practices, but yeah, I mean, a lot of people do use PyMOL in sort of that way. And I know a lot of people typically go to like our package on like CondaForge, where you can also have access to sort of like other scientific packages, and you can just, import PyMOL to just do something very quick things like calculating, solvent accessibility, do alignments, like distance calculations without even having to pull up PyMOL itself. But as far as back processes, I probably have to think about it. But
I think there
I can't
is
think of anything else.
I think there is an old, again, I would encourage you, whoever's asking the question, to Google it, because I think there is a old mailing list thread that's about this, if I'm remembering correctly, but I've not looked at it in a very long time. So hopefully there's something available on Google.
Any major updates in version 3 and above with regard to these functionalities or in general the API itself?
Right. No. So our goal with PyMOL 3 development, especially with regard to headless mode and just like kind of the overall API, is we try to minimize the change as much as possible. So if we are adding things to the API, it is generally strictly additive. It is not meant to disrupt. Because again, I keep talking about the history, but people have written these scripts over the last 10 years or whatever, and we want them to be as stable as possible, right? Our goal is not to just change things out from under people's feet, and especially if they've been in a lab and, for a very long time, they've used this program for a long time, we don't want to have it all of a sudden break one day. That's not always possible because there's lots of dependencies and various packages that have changed over the years, but as much as possible, we try to keep the actual PyMOL API stable.
From a software development perspective, how difficult is it to maintain this backward compatibility? Because it's something that we face quite a bit in the PDB as well.
Yeah. It's very challenging, especially for particular plugins. We have a plugin, we have several different plugins that oftentimes are reliant on developers or packages that are no longer working on it, right? Like again, that's just the nature of software over the years, right? Things kind of become outdated. And I'd say that's one of the bigger challenges, is just keeping all these dependencies up to date / figuring out if we need to rebuild something ourselves or what that looks like. And then that also delves into kind of weighing our options, right? Should we work on the actual PyMOL product and improve these other features versus, kind of continuing to maintain some of these older plugins that are only used by a handful of people, right? That's a literal trade-off that we have to make. But yeah, there's not an obvious or easy answer.
If the inspiration for the question is if they come across some pain trying to use the Python API, I would love to hear it because I haven't heard much. But if there is, I would love to hear how we can improve.
So first of all, PyMOL is very useful. I use it for almost 20 years since it's like 0.99 version in my graduate. So if you can go back to the page where how this rocking ligand, you indicated you use 5 seconds to create.
Yeah.
So this is, I guess it's ATP, and it binds to that protein through the phosphate bond, correct? On the far side.
Yes. So this is.
But it doesn't show that bond. So my question is it because the bond definition was not in the input file? It's between the ligand and the protein, I guess, or nucleic acid. Was that because it was not in the input file, or is it because you don't read that information?
I made this a long time ago. There's two potential answers here. One of which I think it may just be how we're rendering out the cartoon. So basically, like how we actually draw that cartoon. Essentially, it just draws between the actual like backbone of whatever nucleic acid that you are displaying. I'm not sure if it recognizes that final ligand as being part of that kind of continuous chain. I believe it's part of the structure. I pulled this actually from one of our online courses. The drug that's displayed here is a HIV drug. Very, very famous structure, very cool if you look at the full thing. But I didn't look at the actual like file itself to know if this ATP was added after the fact or if this was actually part of the main structure.
I mean, in the general question is when you read a file, it could be MMSIF, could be a PDB file. Do you have a documentation of what information are read through, into this browser? I mean, the viewer. Because, of course, citation information is useless. If you don't read it, understood. But if other information such as structure count in CIF or link in PDB file, do you read into, and consider that as valid input information or some other information?
If there's fields like connect, then we would use that information. But if there usually isn't, PyMOL will try to do some guessing as far as like, is this like a covalent bond or is it like not? Sometimes it will miss, but if the PDB does provide like bonding information, it will obviously try to use that as priority.
Do you have a documentation indicating what information I use?
PyMOL documentation can probably improve.
In that, okay.
Yeah. I'm not sure that everything's, and I would say also some of the more information-rich formats have changed again over the years. I'm thinking of even just like mol files and the ability to add more like actual structural annotations and structural properties. We do read those in, but it's not always easy to display them, or we don't always know what to do with them. And so I think that's another thing that we're currently working on improving, especially with, again, mol files and some of the other Schrödinger structures that have particular properties associated with them. Yeah.
I agree.
Yeah.
There's one question here. Are there plans to integrate NVIDIA optics for real-time ray-traced ambient occlusion? Would be nice for teaching engagement.
The answer will likely be no, because of probably the answer I gave earlier. We're going to be looking at Vulkan for ray tracing, and we're going to implement a shader for real-time ray tracing with ambient occlusion. The obvious reason is for cross-platform, availability. If the NVIDIA optics approach only works for like NVIDIA cards, and we want to make sure that anybody who opens up PyMOL with a decent GPU, especially if you're like on a MacBook or have an AMD card, that this will work for you. So I will always usually go for like something a little bit more cross-platform rather than something that's more vendor locked.
Okay. I know you were talking about the PyMOL documentation and everything. I used to rely heavily on the PyMOL wiki.
Oh, we still do.
And so that's still being supported and maintained. Okay.
Yes, as much as we can. We did have a recent snafu, so I think it's back up
Yeah.
now. Yeah. Sorry, one more question in the back. That was a very quick one. You can, I don't know that. I can repeat the question as well if you just want to.
Okay, we have.
I'm sorry, I just had a question about the movie scenes.
Yeah.
And you said you could rearrange them, make the movie in any way.
Yeah, I'll show you in a
Can you
demo.
specify specific time delays or how much time goes from one to another, or does it have to be done in a different platform?
We could do it all here in PyMOL. If you want to see a demo, I'm sure Thomas would love to show
that's
you.
what I'll be primarily focused on. Cool. All right.
Okay. Do we have one more question here, maybe? Yeah. Okay.
I just have a question about the AlphaFold. So like I use AlphaFold, and then when I use it without like this being implemented into here already, when I do it on the website, and then you have to convert to PDB by yourself, but like it doesn't just come when you download it. And then when I pull it, the PDB, I converted myself into PyMOL. Is it the exact same that it was shows on like PyMOL 3.0, the version you have here? Because I don't know when I convert it by myself, anything is missing or like fonts or anything are changing, or like it will be exactly the same if I do it myself or like the.
Are you asking the way you do it now will look like this?
I just don't know how you guys implemented AlphaFold 3 onto like PyMOL. Is it like, do you convert it from?
Oh, we grab it straight from the AlphaFold database. So we take their corresponding like CIF files and their JSON to create like or we get the coordinates from the CIF file, and they also provide like a JSON file for their like PAE viewer.
And for the bonds, like for this predictions, how did you guys like define like what are the bonds, or like how like they
For the bonds within the model?
Yeah, because like a prediction, it doesn't come with like experiments. It's not like a PDB or like, because so like how would you say like they're like how did you treat them differently compared to like exact experiments?
As far as I understand, I thought that the coordinates were in the CIF file. Yeah, that's what I thought. Yeah.
So you do take the CIF file from AlphaFold database, the model
Correct.
CIF
Yes.
file, and then read the coordinates.
Yes.
Any other information you take from that, or only the coordinates?
For now, just probably the coordinates and any other like CIF sort of field that we usually read before.
Okay.
But I would probably have to see. But we are looking into other sort of keys as well, and we'll probably talk about that later offline.
Okay.
Yeah.
Yes, and we will probably make a change to this soon. We're still sort of exploring, because I know there's been sort of some pain points trying to sort of overload the B factor with stuff like PLDT or PLDDT. But with CIF, I think this gives us probably a better idea of maybe we can maybe access PLDDT through just like a property rather than the B factor, but we'll probably investigate this.
Yes, you don't have to use the overloaded B factor.
Yeah, exactly.
This is exactly what I had in mind earlier when I was talking about the different formats, by the way. But literally, this is what the AlphaFold developers use as well. They use PyMOL and they use the B factor. And again, they have like videos online of them using I believe the open source version of PyMOL, but they're using that as the main viewer as well.
You use the JSON for the PAE rendering.
Correct. And I know, as far as I understand, there is a model archive that has another key for this, and
yes,
I think that will probably be in the next version too. But
okay,
we'll probably have to talk to some folks about that offline.
Yeah,
but yeah, that's our goal.
In model CIF and model archive supports.
Yep.
Correct. All right. Okay. So with all the questions answered, maybe we can move on to the demo. It was good that your talk was shorter.
I know,
because we had a lot more questions coming from our online audience and in person.
No, absolutely. I mean, that's what we're here for anyway, right? It's mainly for the questions. So I will do a very, very short demo. I also have a more complicated example that I am working on for a paper right now, actually. But I will pull up PyMOL. This is also not a release version of PyMOL. This is just our latest version of master. I'm sorry if this is going to be hard to see as well. I'm sure online this is a little bit easier to see. But yeah, so this is the new PyMOL 3 interface. Let me minimize this. Does anyone have a PDB code that they would like me to pull in since we're here? Protein with a ligand, preferably. 2HYV. All right, awesome. Look at this, great. So I'm going to just basically show, I'll make this look a little prettier real quick. Okay, cool.
Next with the carbohydrate, with the oligosaccharide.
Oh.
Also with cat.
Interesting. Okay, sorry, I'm just doing a few quick things real quick. Okay. So the main thing that I want to demonstrate here is the creation of these scenes and how helpful they can be. So again, when I was talking about scenes before, first of all, you can open the scenes panel from here in the top right. But when I was talking about scenes before, I was referring to them as checkpoints. And I think that's really a good way of thinking about this. So as you are manipulating the structure and making these changes and kind of investing your time in trying to make something that looks nice, it's very, very helpful to be able to have these checkpoints that you're able to go back to. So we're able to store scenes just by clicking this plus button or save scene down here at the bottom. And I usually do this like whenever I first load in a structure. I just save a scene and then, we'll zoom. I'm actually curious if this, yeah, nice. So this is going to detect this whole thing. We can also save a scene that looks something like this, right? And then now we can just click between these, go back and forth. sorry, the animation looks very slow on the projector. It's not that slow on actual PyMOL. This looks very, very smooth. But the idea here is, again, you can switch between these two views very, very quickly. We can do something that's a little bit more of a drastic change as well. So if I change this to, sorry, actually that's good. We're just gonna hide solvents. And we will hide our cartoon or show, again, I'm just doing something that looks dramatically different, something like this, right? Save another scene like that. So again, you can just switch quite easily back and forth between these different scenes. So now, again, I will create a movie that just kind of rocks back and forth or shows this kind of like zooming animation. To do so, we're going to open the timeline here in the bottom right, which is this movie camera icon. Again, I'm sorry if this is difficult to see. This is challenging for me to see because I have a whole bunch of zoom overlay stuff. One moment, sorry. Okay, but you can basically just drop these scenes directly in. I believe on this branch, you can even just drag them in. Yeah, there you go. So we can create a movie very quickly, just dragging these two scenes in. And I will reorder them real quickly. We'll do something like this. And then just like that, in just a matter of seconds, we now have a movie that will do this kind of zoom in and out, right? Again, this isn't the perfect movie and it doesn't look very good on the projector, but you get the idea of being able to create something that's going to show you this 3D representation very, very quickly, right? Then we're very short on time, so I'm going to kind of fly through this. But if you want to kind of add these other camera positions as you go, we can use the timeline inspector here on the right. So this provides a whole bunch of information in terms of the scenes themselves, right? You can pick whichever scene you'd like, the camera position, so we can store using this rhombus, or yeah, the rhombus right here. And then now it's going to kind of like pull out to this other camera angle and then go back to the other one, right? So the idea here is that you can very easily manipulate these things, though. So the question before that we were asking about timing, you see the little time ticks here. Again, I'm sure this is challenging to see on the projector, but the idea is that you can adjust the timing very, very easily. In previous versions of PyMOL, it was very, very challenging to kind of like change the overall timing here. But if we want to, again, kind of move these things as a group, move this unit over, it's now, again, very, very easy to just drag these things around. Let me see. I'm trying to think of, we don't have very much time. I'll switch to a more complicated structure now. But before I do, any questions on this very, very quick, just like make a movie that I just showed you? Cool, very simple. The whole point that I want to convey with this though is that you can literally create a movie in just seconds. And then when you want to export it, you can choose this export comp option. And then there will be a whole bunch of different options in terms of the exact outputs. We encourage you to use MP4, whatever resolution you want. The biggest thing that I would like to say with this, though, just in general, is we don't have the real-time ray tracing implemented yet. So if you want to ray trace these movies and you have something that is 30 seconds or a minute long, it can take hours because you are essentially rendering out a full like 4K ray traced image for each of the different frames. In the future, that won't be as much of a concern. But the point that I want to convey with this is when you are playing around with this, please export drawn movies first. They will go very, very fast. And then if you are very happy with something and you want to create this really, really nice looking ray trace version, especially for longer movies, then do ray tracing second. Okay, all that to say, it's cool. It's a very easy feature to use now, and I'll show you the more complicated example as well. The last thing I want to highlight with this initial simple example is the draw ray button here in the top right. This is what's used to export images. So if, again, you just want to play around with this and export an image very quickly, we have the option to specify whatever size image you'd like, and then either draw the image, which will be much faster, or ray trace the image, and it'll have much nicer looking lighting. I'll ray trace it real quick. Again, I'm sorry if this is difficult to see, but you can see there's nice shadowing on these helices, and you get much more of a real 3D look effect. Cool. All right. So to pull in a more, to pull in a more complicated example, this is one that I'm working on with a membrane-bound protein that's doing flexible docking. Again, I'm working on this for a paper. This isn't going to be very pretty because I'm like in the middle of it. You can see this is this is what I was alluding to before with the script that's going to label these individual helices from the paper itself. But what I want to show you is that we have a movie here that is going to incorporate not just camera positions, but we have a whole bunch of water molecules that are moving around there at the top, and they're slowly fading into being fully transparent. We'll see if I show that again one more time. You'll see water molecules fully shown and then just kind of like slowly fading away. The feature that I want to highlight with this, though, is the individual setting tracks for this. So we have a setting for sphere transparency that is going to be set by a value at this node and then slowly interpolate to 0 here. And within the timeline inspector, you'll see this sphere transparency shift from, I guess it would be opposite. So it would be 0 to 1 of being fully transparent. And so again, the main point that I want to convey with this, it takes some time to actually play around and create these things, but you can really layer in multiple different elements of the story. What I'm planning on doing with this larger structure is showing this full membrane initially, and then slowly fading it away. So you understand the relative position of this structure within the membrane. Then you zoom in, you see what we're actually doing with the solvent and how it's all kind of clustered outside the membrane, and then moving into actually looking at how the individual residues of the binding pocket are flipping. I'm not sure you can see it on this yet, but that's the idea, right? You're able to kind of layer these different elements into the story that you're trying to tell, and really give the audience a much, much better understanding of what not only is happening in this particular simulation, but what is happening in this overall structure. Again, where is the ligand relative to the membrane, all these different things. Okay, I'm sorry I'm flying through this, but we are essentially out of time, and I do want to leave just a couple minutes at the very, very end if there's any other questions or for an outro. So open up any last questions on any of this. What's up?
Complex great trace animations. Do you really have to wait like hours and hours and hours?
Hours and hours. I might be a little dramatic. It shouldn't take that long. Again, a lot of this will be solved by us having actual real-time ray tracing and not being entirely reliant on the CPU. Because again, what is literally happening right now is we are using the CPU to render out a whatever size image for each frame within this. So again, if you have a 30-second movie and it's 30 FPS, right? I think, yeah. So whatever that, I mean, 900 ray traced images, right? That is going to take quite a long time. But again, once we can actually use the GPU and do this in real time, then it should be essentially the same length as the movie itself, right? As if you are just playing through it. So that 30-second movie now just takes 30 seconds ideally.
I had a question. So
yeah,
if you want to render something like a membrane as a coarse grain, something like a torus or a half torus or something, some generic geometric object, would that be?
Yeah, absolutely. So PyMOL has CGOs, and even actually, I don't know if it's in this image or not. Let me actually see. I can pull in. We have this, I think, is going to show it. Yeah. This actually shows the membrane with just a whole bunch of spheres and dots. This is kind of the depiction that we often use when we don't want to render everything out, but you still get the general idea of where the membrane sits. But you could very easily kind of align a CGO object, which is, again, just a torus or whatever shape you want within PyMOL. There's commands for creating CGOs, and then you can move them around in the physical space to align with something like this. But again, the primary thing you're trying to show with the membrane is just like what part is within the membrane and what is not. And something like this does a good job of conveying that as well.
Sorry.
I was going to say we're probably also going to look into coarse grain sphere representations too. So instead of having a sphere per atom, we may look into having more coarse grain, so you don't have to look at so many spheres at once.
Right, and we have integrative structures now in the PDB where you can have multi-scale representation of the molecule, and then you can have the membrane as another representation. And
we're working on that too as well. Yeah.
Okay. The other question is, with PDB data itself, how about visualizing validation data? We have that in MMSIF as a validation metrics you can get that in SIF, and if you can take that information and visualize that along with the structure, that would be very useful.
Would love
can
to
you
hear
consume that?
Yeah, I'm curious what would be the most helpful way of displaying that information.
Because
Yeah, absolutely.
Okay,
Yeah.
we can probably get into that discussion, but in general, that's also available and
Right.
could be consumed.
Absolutely. All right. Well, we are at time. So thank you everybody for listening. And have a good afternoon.
Thank you. Yeah, thank you everyone.